Welcome back, everybody. We are looking at example 3 on page 95 of the workbook, and this is another opportunity to work with the definite integral, this new definition that we introduced. Let's read this problem together. So it would like us to use a middle sum with n equals 4, that's a new word, to estimate the value of the integral from 0 to 16 of sine of x squared over 40 dx. Okay, and remember that that definite integral had something to do with exact area. And that was what that symbol represented. And the 0 and the 16 was a way of telling us the interval that we're interested in. So 0 to 16 looks like this over here on our picture. And they're telling us to divide that into 4 equal pieces. That's the n equals 4. So if we do that, we are chopping our interval up into pieces of length 4. Okay, now what do we mean by a middle sum? Well, that just means that for each of those 4 intervals, what we are interested in is the middle point. Okay, so I'm going to mark the middle point of each of those 4 intervals, and go ahead and just write down the number that's at the middle point. So halfway between 0 and 4 is 2, halfway between 4 and 8 is 6, and so on. And we're going to use those middle points as the basis for the rectangle that we draw. Okay, so for example, at 2, we're going to go up until we hit the curve, and we're going to use that middle point function value as the height of our first rectangle. We'll do the same at 6, go up until we hit our curve, and we'll use that number as our height. We're going to keep doing that, using our middle points as the place where our rectangle hits the curve. Notice that at 14, we actually wind up down here below. Get a rectangle that's down here. Okay, so there are the 4 middle sum rectangles, and now we're going to see if we can use that to estimate the integral from 0 to 16 of our function. Okay, well, how do we do that? Well, we're going to use the same idea that we did with left sums and right sums. So estimating area is about taking function values and multiplying by width. So we would start with our first rectangle. We notice that we plugged in 2 to get its height. So we're going to be taking f of 2 times the width. And what is the width of each of our rectangles? You can see from the picture that each rectangle has a width of 4. So we're going to get f of 2 times 4 for the first one. Then we move over to our next point, f of 6 times 4. And then 10 was our next middle point. So f of 10 times 4, and then finally f of 14 times 4. Okay, and we'll do the same thing that we did with the left and the right sums. Notice that we've got a 4 in every single one of those terms, so it's kind of nice algebraically just to factor that out. And then we need to calculate our function values one by one, starting with f of 2. So we're going to take 2 and substitute it into our formula for the function. So that's going to give us a 2 squared over 40. Okay, and then we come to f of 6. That's going to be a sine of 6 squared over 40. Okay, and so on down the line here. And now we're ready to go to our calculator, and you're welcome to punch these numbers in. The caution that I'd give you is, since we're working with trig functions, you want to make sure that you're in radians when you do this calculation. I'm going to go ahead and show you the numbers that I got, just rounded off to 4 decimal places. So sine of 2 squared over 40 is about 0.0998. Then sine of 6 squared over 40 is about 0.7833. 0.5985, and then finally negative 0.9825. Notice that that last number is negative, and kind of makes sense if you look at the picture, because when you substitute 14 in, our function is actually below the x-axis, so we got a negative number there. Okay, and you can punch all of this in and get one answer. We're going to come up with 1.997. That's our estimate of the integral. Okay, now there's one important note that we can make that kind of came up in this example that we haven't seen before. The fact that we got a negative number over here tells us something interesting about how definite integrals work. Okay, so the thing that I'd like to make sure that you write down somewhere is that that negative sign tells us that that last rectangle, the fourth one on the very right, actually got subtracted, not added. And the reason for that was that f of 14 is a negative number. Okay, so what we can say this about a definite integral is the following. So in general, if a function is above the x-axis, area is going to get added, and when it's below the x-axis, area is going to be subtracted. That is built into our definition of the definite integral. Area gets added, and when f of x is below the x-axis, area gets subtracted. Okay, and we'll continue to see this behavior in future examples that we do.